Hi, I'm Kyle, and I'm here to explain Lab 4 oscillations. In this lab, the goal is to predict the motion of extreme sports with ropes, which can be simplified to spring oscillations. The physics principles E equals W plus Q, which means that energy equals work plus thermal, which is dissipated energy. And then force of spring equals negative K times L minus L naught. And finally, Newton's second law, Vf equals Vi plus F net divided by mass times delta T, which we use to calculate position and velocity. Um, Now let's look at the force diagram. So the hanging mass in green, and then the spring force is always pointing in the up direction, and the force of gravity is always pointing in the downward direction. Okay, let me show you the motion in tracker. So as you can see, the hanging mass goes in an elliptical motion, and then you can see the oscillations in this table, in this graph, and the data table, which I saved as a CSV file, which was later used to compare to the code model. After I ran the code, I got this graph. The green is delta U gravitational potential energy, and the red is the spring potential energy, the blue is in kinetic energy, and the total energy is the yellow line. Which makes sense because delta U and delta UG and delta US are inversely proportional, and total energy should always be constant and zero in this system because no work is applied to the system. Afterwards, I compared the model to the experimental. The experimental's in red, the model's in blue. As you can see, the model, the model, yeah, is slower than the experimental. It's also a lot smoother. The experimental was a lot faster than the model. And finally, let's look at the conclusion. What does it mean? The energy principle is satisfied for the model system because if we look at the graph here, energy is conserved because total energy is constant and zero. And so that proves that this model satisfies the energy principle. And I use the graphs in Tracker to help me calculate the estimations of my periods of oscillation. This is the time compared to X graph, and this is the time compared to Y graph, and I just looked at each of the lowest points, and then I subtracted to get the difference, which is the oscillation. And here, for the Y position, I got 1.53, 1.42, 1.62, 1.42, and 1.62. The average is 1.52, and the median is 1.62. And for X, I got 1.62, 1.61, 1.71, 1.62, and the average was 1.64, and the median was 1.62. Excuse me. The average Y position base period is smaller than the average X position base period. This would make sense because gravity is acting in the Y direction, and the X direction has no force acting on it. However, the median of the two periods are the same. That's because it is two representations of the same motion, so the numbers are bound to be similar. In an ideal situation, the X and Y position data based periods should be the same. Thank you.